Hello everyone, you're the math nerd and I am the craziest math nerd of all, Kitty Morgan. I'd like to talk a little bit about AP flavor that has to deal with differentiability of piecewise functions. So we're going to look at page 73 from Master Math Mentor. This should be in your student packs if you have those. It's at the bottom of a page, and this is the ultimate question. I see it all the time in AP. So it says find the values of A and B that make the function differentiable. Well, notice that we're going to work on A. Let's look at A. Notice in the A, it is a piecewise function. So we want to know if it is differentiable. So in order to be differentiable, it must be continuous, because that's our discussion we had before. In order for you to be able to draw a tangent line to a point on a function, that's what differentiable means, it has a slope of a tangent line, you must be continuous. So there are two parts to this. The first part is that I need the function to be continuous there. And when I say there, this is a parabola. This first piece is a parabola, and we know that parabolas are nice and continuous. The second piece is a line, and lines are nice and continuous. So the only place we're really worried about is this place where the piecewise function breaks up. And so what we need to do is we need to see what A and B would be if both sides of that function were the same y value, so that both sides come together at x equals 1. So what you do is you plug in x equals 1 into both pieces, and if you want the y's to be the same, you want both pieces to match, then you want to plug in x in 1 in for x, so that's a times 1 squared plus 1. You want those two pieces to be equal, so b times 1 minus 3. So the first part is to plug in the x value and to force the y values to be equal, because that means both pieces would come and meet. And so that is a plus 1, and that's equal to b minus 3. And notice this is not really helping me a whole bunch, because I have an a and a b, and I can't solve for either. So, wow, what do I do now? Well, something else must be true in order for a point to have differentiability. And that is that the slope from both sides must approach the same thing, because if they don't, then we know that this is not a smooth function. So how do I find the slope? So I'm going to go over here and find the derivative of this piecewise function, and that's going to be 2ax plus nothing for x less than or equal to 1, and the derivative of this is going to be b for x is greater than 1. And so what I've written are the slopes of both pieces. And so these slopes at 1 must be the same. So I'm going to plug in 1 to x. So 2, this is the second part. So 2a times 1 must equal b, which means that 2a is equal to b. Again, we have a statement with a and b both in it. But now we have two statements. We have a statement about continuity and a statement about slopes that are talking about the same a and b. So I am going to get another color pen, because y'all know I like my colors. And I'm going to take this statement and actually plug it into that statement, okay? So where I see, so I'm going to write a plus 1 is equal to, and b is 2a minus 3. Could I have solved this for a and put that in right there? Sure, I could. I mean, it doesn't matter who you solve it for, just solve it for one of them. And then I'm going to combine this, so that's negative a is equal to, and that's going to be negative 4. And so a is equal to 4. Well, if a is equal to 4, and I put that statement right there, then b is equal to 8. So that is the value of A and B that make it differentiable. Now here's the part that's tricky on that. When you say differentiable, I didn't say continuous and differentiable. But remember, when we talk about differentiability, that means that the function must be continuous. Okay? All right, I'd like for you to try B. So I want you to stop the video and try B. And when you come back, I will show you my work on this problem. All right, so let's go through those steps. Step 1, prove that it is continuous. So you take your value and plug it in for x and set them equal. And you should have something with an A and a B. Take the derivative of each piece, find your derivative piecewise function. Plug 2 in for x, set them equal, solve. Take the solution of one of those, and the differentiable function's easiest. Plug it into the other one. I did that, solved. I got A was 9/14. And when you plug that back into you can plug it into either relationship. I just plug it into the easiest one. You get B as -27/7. All right, hope that helps. And y'all have a great day, and don't fall to pieces over piecewise functions.